Hello there, and welcome back to the channel. It's 2025 September 16th, a lovely Tuesday. And you know what that means. It's time to pull a really cool, charming article from the archives. And now your host. And today we've got a real franker for you. Let's dive right in. So I was browsing through the latest papers, and this one just jumped out at me. The title is The Acoustic-Semantic Mitigating Acoustic-Semantic App via Echo Training for Speech-to-Speech LLMs. The crawl is Text-to-Codec 179,974 of them. It's long. Okay, so what on earth does that even mean? Let's break it down, cause this is super interesting. You know how we have these amazing AI mini hypots that can write poems and code, like the big text-based models. Well, people are trying to make them talk. Really talk speech to speech. You talk to it, and it talks back, no text in between. Think of things like that for is really small. But here's the problem, they found a weird one. You take a super smart text AI and teach it to speak. It kind of gets a little bit dumber. Yeah, its knowledge and reasoning skills start to degrade. It's like how you teach a calculator to appreciate jazz. You can play the notes, but can feel the blues? Maybe because it's not a saxophone made of beans. Nobody gets it. Anyway, the researchers behind EchoX think they know why this happens. They call it the Acoustic-Semantic app. That's the core idea here. So imagine you're a text AI. If you're supposed to say hello, but you say hi instead. Meaning is almost the same, right? So you get a very small penalty. The AI learns that words with similar meanings are good. That's semantic learning. It's learning meaning. But for a speech AI, it's totally different. It's not learning words, it's sounding sounds. The sound of hello is completely different from the sound of hi. So if the AI says hi when the training audio was hello, it gets a huge penalty. This forces the AI to focus on matching the pronunciation perfectly, the acoustic part, instead of focusing on the meaning, the semantic part. This creates a conflict gap. The model is torn between sounding right and being smart. And that conflict is what causes this intelligence degradation. It's a fascinating problem. So how does EchoX solve this? This is the clever part. They call it echo training. Instead of using fixed, pre-read audio for training, they do something much more dynamic. It's a three-stage process. First, they train a model to be good at speech-to-text. It listens to audio and understands the words. Second, they train a separate module called the Text-to-Codec module. This thing's job is to turn text into the basic building blocks of speech. These things called speech tokens. And third, this is the magic step that can guide them for echo training. The model listens to a user's speech, and internally, it figures out a text response, just like a normal chatbot. And then, instead of trying to match that text to some random audio file, it uses its own Text-to-Codec module to generate the target speech tokens on the fly. It's basically creating its own training goal based on what it wants to say. It's learning to match the sound to its own internal thought, its own semantic understanding. It's like it's listening to an echo of its own intent. That's why it's called EchoX. This bridges that Acoustic-Semantic app. Super smart stuff. Oh, and they also use a couple of other cool tricks. They use something called unique language, which is a way to compress long audio sequences into smaller word-like chunks, making everything much more efficient. And they use streaming generation. So the AI can start talking before it has finished its entire thought, making the conversation feel much more natural and real-time. So, what does this mean for us in our daily lives? This is all about making voice assistants genuinely intelligent. Not just glorified voice-controlled search engines, but real conversational partners with reasoning abilities. Let's think of some examples. First, in the world of chatbots and dialogue systems. Imagine calling your internet provider. Instead of a robot that can only understand keywords, you get an AI powered by something like EchoX. You could say my Wi-Fi is slow, but only on my laptop. And only in the evenings when my neighbor is probably streaming something. The AI could actually reason through that. understand the nuances of your spoken problem, and give you intelligent troubleshooting steps, all in a natural voice. Second, for machine translation. Right now, real-time voice translation is often very literal. It translates the words, but not always the intent or the norms. With this tech, the translation app could listen to you speak, understand the underlying meaning and context, and then generate a spoken translation in another language that sounds natural and is culturally appropriate. It preserves the intelligence behind your words, not just the sounds. And a third one, information extraction and text summarization. Think about doctors. They often dictate their notes after seeing the patient. An assistant with EchoX would listen to these spoken notes, and then generate a perfectly formatted text summary. It could even speak a summary back to the doctor saying, "So, to confirm, the patient presents with these symptoms, and your primary diagnosis is this. Is that correct?" That's passable because it's not just transcribing. It's understanding the spoken information deeply. And when you compare this to other technologies, it really stands out. There's one method called interleaving, where they'll try to train the AI on speech and text at the same time. A paper says this can work, but you need a mind-boggling amount of data, like millions of hours of audio. EchoX gets comparable results with just around 6,000 hours, which is way more efficient. The other approach uses a separate decoder, which is similar. The EchoX's whole echo train idea of dynamically generating its own targets is to be the key that really closes the gap between sound and meaning. So yeah, EchoX is a really elegant solution to a very tricky problem. It's about letting our voice eyes be as smart as their text-based cousins. Pretty cool stuff to think about. Alright, that's all the time we have for today. Thanks for tuning in. And then and I'll catch you next time with another gem from the archives. Stay curious, everyone.